Welcome to our Math 170 first module, Module A. It's going to be a review of equations and inequalities. And let's just go ahead and get started. So first we're going to take a look at solving rational equations. Rational equations are ones that appear as a fraction. And so let's go ahead and take a look at this one. How would we go about solving this one? Well, the first thing we want to do is when we have a variable in the denominator, again, what we're trying to focus on, our answer is going to eventually look like the variable equals some number or some expression. So we want to get this out of the denominator. And so the first thing we're going to do is we will multiply by the denominator's expression on both sides. And working with equations, since they're equal, they're balanced, the way we keep them equal and balanced is to do the same thing to both sides whenever we do it. So we're thinking that we're now multiplying by w plus 8 really over 1. And so this, when we multiply two fractions, numerators times numerators, denominator times denominator, the denominator now and the numerator factor, those two factors are the same, so that's a factor of 1. They cancel out. And so that really simplifies our left-hand side. We're left with just 5 over 1, or just 5. On the right-hand side, notice we could think of 2 as being 2 over 1, so we've got our numerators lined up. And so what we're going to do here is we will just go ahead and, in this step, distribute the 2, and that gives us 2w plus 16. And now we have a linear equation where we just want to get the variable isolated, get it by itself. And so what we will do here is, since we're focusing on the variable, remember we do opposite operations in the reverse order. So what I'm meaning is usually we would multiply by 2 and then add 16. But what we're going to do is we're going to first subtract 16. And again, we do that to both sides. And then we're going to take care of the 2, but we're not going to multiply by 2, we will divide by 2. Anyway, 5 and negative 16 is going to give us negative 11. And so then now we're going to divide both sides by 2. Or multiply by 1/2, however you want to think of it. But 2 divided by 2 is 1, so that gives us just our w. And then negative 11/2, that doesn't reduce down any further. That is our answer. Could write it as a decimal, what's that going to be, 5.5, but that's solving a rational equation. Complex numbers. Sometimes we need to use complex numbers. What are they? Well, first of all, they come out of this need to take the square root of a negative number. Now, when we're taking a square root, what we have is, we'll just take like 16, the square root of 16. We're looking for a number that multiplies by itself to give us 16. And that's going to be, 16 is 4 times 4. So the square root of 4 is 4. So that's a way, the square root is a way to get at the number that when you multiply by itself gives you the number inside the square root, right? So the question comes up, is there any number that when you multiply by itself gives you a negative 1? Well, let's try. How about negative 1 times negative 1? Well, no, that's positive 1. Same thing, positive 1 times positive 1 gives us positive 1. There's no way to multiply a number by itself to get a negative 1, let alone negative anything, right? So the way to make this possible is to creatively come up with a solution. We will just say there is a number that when you square it, it's equal to negative 1. We don't know what it is, so we'll call it an imaginary number because we're using our creativity at this point. So I is the imaginary number. Now we don't know exactly what I is, but we do know, because we defined it this way, that whenever we square I, we get negative 1. And so what that helps us is that since there is this number, right, like this 16 here, what we knew is that when we take the square root of 4 squared, we're going to get 4. So when we take the square root of I squared, we're going to get I. And see, we don't have to worry about negatives in here now. And what we've done is that we've defined that if we have the square root of negative 1, because of this definition right here, I squared equals negative 1, we can make the substitution and it follows through. Yeah, we can take the square root of a negative number. And so what this does in practice, let's come back over here. We've got our, if we needed to take the square root of, say, negative 16, we would look at this as the square root of negative 1 times positive 16. And some properties of square roots, when we're multiplying, when we've got products, we can actually separate them into separate square roots. And so now we can take each of these because we've got a definition, and we don't define every negative number. We only define one, negative 1, that I squared is equal to negative, and that's all we need because we can always take this part out. And so what this becomes, square root of negative 1 is I, square root of 16 is 4, and just because that looks kind of strange, I, 4, we always write the number first, and so 4i is what we would call an imaginary number. I've got a few notes here. Hopefully I haven't written over them. They're pretty good. So a complex number has an imaginary part. That's this little bi thing. B is some number. And it has a real part, which is just the number a. So in our case so we'll look at what it was 4a as a complex number. It's really 0 plus 4i, where the a part is 0, the b part is 4, and that's what we define a complex number to be. So if b is 0, then if b is not equal to 0, let me read correctly, then certainly we've got an imaginary number, and this would be called a pure imaginary number, like we have down here. This actually here we refer to as a complex number because it's got an imaginary part and a real part. And if b is actually ever equal to 0, then it's just a real number. The imaginary part doesn't exist. Does I actually exist? We don't know. But the interesting part is it is useful mathematically. And if you ever get into electronics, all our electronics today, the phones, all this miniaturization, it's possible because what the programmers are actually using is imaginary space. They're using this imaginary number to compact code and space on a chip. Don't ask me how it works. I'm not an electrical engineer. I'm not sure they understand, but they're using imaginary numbers to make all these miniaturized components. So yeah, sometimes you make something up and it actually works. So we've got these numbers. How do we work with them? Well, we're going to look at just adding, subtracting, and multiplying. If you look in the notes, you'll see an example of division, but in the homework, all we're going to ask you to do is add, subtract, and multiply. So first, how do we add two complex numbers together? Really, we look at this as when we add, we can remove the parentheses. We don't have to worry about, I guess you could think of, we would just distribute this positive, but a positive doesn't change anything when you multiply through by positive 1. So I'm going to kind of just say, let's remove these. And then what are we doing? Well, really, all we're doing is combining like terms. So we've got 6 and 3, and they're both positive, so we're adding them together, we get 9. The other parts that are like term are these terms with I, so treat the I like it was a variable, although it's not a variable. Remember, it is a number that when we square it gives us -1, but we treat it that way, so we've got -6i, -5i, that's going to give us -11i for the complex number 9 minus 11i. How do we subtract? Similar, except we do have to be careful that when we multiply through by a -1 is going to change the sign of each of these. So we do distribute through as we take off these parentheses, and we're going to rewrite this as 2 minus 2i. We get -4, and a negative times a negative is +3i. That's the biggest error I see is not distributing through. Some students will take that negative, distribute to the 4, but not to the negative 3. Okay, and then again, we just combine like terms. 2 and 4 are like terms. They're both numbers, so 2 minus 4 gives us a negative 2. And then i's are like terms. We've got a negative 2 and a plus 3. That's going to give us a plus 1i. And so we end up with negative 2 plus I. We'll do it in green. That's fine. Multiplying, this is maybe the most complicated part, but not so bad, you know. What we have is two binomials. They each have a term. And so all we're going to think of as FOIL, treat the I as if it was a variable, as if it was an X. The only thing is when we do get an I squared, we're going to see we can convert that back to negative 1. Remember, I squared equals negative 1. So we're going to do that. So we first multiply the first FOIL, right? First, 6 times 2 is 12. We multiply the inner, that's these two. FOIL. You can actually do it in any order, but let me just, first we do the outers. Okay, so I usually don't do it that way, but anyway, so the outer terms would be the 6 and the 4i. So that gives us a negative 6 times 4 is 24. We do the inners, and we get a minus 5, 5 times 2, we get a minus 10i. And then finally, we do the last, negative 5 and negative 4. That's going to give us a positive 20i squared, I times I. And now we can combine like terms. So we get 12 like terms in the middle, negative 24, negative 10, that's negative 34. And then we've got to do this substitution here that I squared is equal to negative 1. So we get 20 times negative 1. That's going to give us a negative 20. Oops, we're not quite done yet. Now we've got like terms again, 12 and negative 20. So that's going to give us negative 8 minus 34i. And that's how we can add, subtract, and multiply complex numbers. And you'll have some of these type of questions in the homework coming up. So let's move on to the last sort of portion of this review, which is going to take a look at how do we solve quadratic equations. So we started with solving the rational equations, and we're going to jump right into quadratics. And there's a couple different ways to go about this, but we'll take this first stab at it. If we have a quadratic equal to 0 that will factor, we can do it by factoring. And the way we know that this can factor is that we look at this last one. Well, that's either 2 times 12, or it's 4 times 6, or it's 1 times 24. But then what we notice is that this middle term, if you take 4 plus 6, you get 10. So this should be able to factor. So the first step is to factor it into two binomials. And u squared we get, remember the first part is going to be u times u. The last two numbers have to multiply to give us 24, so they're either going to be 2 and 12 or 4 and 6, but we know that 4 and 6 have to be it because the middle, they have to add together to give 10, and 2 and 12 add together to give you 14. So we'll do a 4, we'll do a 6. And so now that is factored. What you want to do is, kind of on your scratch work, is FOIL it back out. So u times u is u squared. U times 6 is 6u. If you have troubles with these, if you're good at factoring and you've got this, that's great. Sometimes you can just fast forward on down the road for u, right? And then 4 times 6 is 24. So just make sure that it all fits back together nicely. 6 plus 4 is 10. And there's a check, we got back to what we started with. Now the thing we're doing here is we're taking advantage that if you have two numbers, and these are our two numbers, when your two numbers multiply to give you 0, one of them has to be 0, or both could be 0. So u plus 4 could be 0. U plus 6 could be 0. Now, they don't have to be 0 at the same time, but as long as they're 0, one of them 0, when you multiply them, you're going to get 0, right? And so now we solve it. It becomes solving a linear equation, minus 4, minus 4. So that gives us that u equals negative 4. Oops. Minus 6. And again, we do it to both sides. U equals negative 6. There's our two solutions. Separate them with commas. When you get into ALEKS, sometimes they'll want you to separate them as just negative 4, comma, negative 6. Sometimes you just look at the context of what they're asking. They may want u equals, or they may provide that, but just work with the system on how to go through that. Okay, you can also do this graphically. We'll look at doing that in one of the following ones. This one also can be factored, but there's a little bit of work. And notice that we've got a quadratic that's not equal to 0, so our first step is going to be getting it equal to 0. So let's subtract 7w from both sides, since that seems to me to be getting rid of one term instead of two. It's a little bit faster. So then we end up with 0 equals 4w squared minus, let's put it in order, 7w, and then our minus 2. Now, because the first term is not 1, it's a little trickier to figure out how we're going to do this. Now, 4 can be made with a multiplication, either 1 times 4 or 2 times 2. So it gets a little bit more complicated. And then remember the last part, 1 and or 2, there's really only one way to multiply to get 2 is 1 and 2. So let's try this. Let's see if this works. It may or may not. I'm going to take a stab at it, a guess, and let's just see. It's a little bit easier to try 2 times 2 because if I do 1 and 4, then I've got to worry about positioning, but it might be the right answer, right? So when I go to factor this, I'm going to use 2w times 2w. And notice that'll give me my 4w squared. And then now I've got a 1 and a 2, because 2, right, what multiplies give us 2, a 1 and a 2. Now we want a negative 2, so one of them has to be negative and the other has to be positive. And then whenever we have a negative on this back, that means we're going to be subtracting. And so what I look at is, oh, in the middle we end up with negative 7, so whichever is going to give me the biggest product has to be the negative one, right, because I'm more negative than positive. So I see I'm going to get a 2 times 2, so that should be negative, and then that makes this to be positive. And again, I'm going to check. Let's see if that ends up working. Well, I get my 4w squared, the first. When I go for my outers, I get negative 4w. My inners, I get plus 2w, and my lasts, I get my negative 2. Well, I see I matched up with the end and the beginning, but I can see in the middle I'm not getting negative 7. I'm getting negative 2w. Okay, so that did not work. So let's try one more thing. Let's try our 1 and 4. So I'm going to factor it this way. So let's go with 4w and 1w, just like that. And I still got my 1 and 2. Noticing when he's 7, I'm going to say, okay, where do I put the 2? Do I put it here or here? Well, if I take 4 times 2, I'm going to get 8. Right? So I'm always thinking ahead. And then if I subtract off 1 from that, I'll get 7. Well, okay, that's how I get the 7. But remember, it's a negative 7, so where do I want to put the negative? I want to put it on the largest product. The largest product is going to be 4 times 2. That's going to give me my negative 8. So plus has to go there. So let's just FOIL it out. 4 times 1 gives us 4w squared, right? That's that one. If I take the last, I get our minus 8w. Inner, I get plus 1w. And then the last, I do get my negative 2. And that gives us exactly what we wanted to get. We get our negative 7w in the middle. And so that's what we want to work with. Now that I've messed this up a bit, I'm going to rewrite it over here. But that's the tricky part of this, is getting the right combination. And as you practice a little bit, you hopefully will get better and better at it. So again, we separate this. It's going to be 4w plus 1 equals 0, or w minus 2 equals 0. We solve for the variable, so subtract 1 here, 4w equals negative 1, and then we divide by 4. So we get one answer of w equals negative 1/4. On the other side, we add 2 to both sides, and we get the answer w equals positive 2. So two answers. Notice that you always end up with the opposite of what the factoring was. And again, we'd want to write this as w equals negative 1/4, comma 2. So there's using factoring still with the tricky part. Finally, we do have some that we can solve, but there is no, it doesn't factor. We could, again, try this if you were to want to, but it's not going to factor. I'm just going to tell you. And the reason I know, they say use the quadratic formula. So what we're going to do is, what is the quadratic formula? Let's do that in red. It's taking the general form ax squared plus bx plus c equals 0, doing a lot of algebra, solving for x, and what they end up with is that x equals, and it took actually hundreds of years to figure this out, and it took me many years to try to remember, minus b plus or minus the square root of 4ac minus, oops, yeah, it's 4ac, but that comes second. You can, my memory goes as I talk. B squared minus 4ac. There we go, all over 2a. So now we've taken our values for a, b, and c. We're going to plug it into this formula, and we'll have our solutions. Now we may get 2 because we get a plus and a minus. There's instances where we would only get 1. And again, we're looking for, well, we also could get imaginary solutions if we end up with a negative inside the square root, right? So what we've got is our a is 8, our b is negative 8, and our c is negative 1. So actually, let me go ahead and write those down here. So 8, negative 8, negative 1. Plug it into the formula, and we're home free. So we're going to get negative b. So I'm going to do a negative 8. Yes, it does become positive 8, but let's go with that for now. We're going to plug in negative 8b here, and we're going to square that. Notice whenever we square it, it becomes positive. Minus 4 times 8 times c, which is negative 1. And that's going to be divided by 2 times 8. So we plug in the values that we know, and now it's just a bunch of arithmetic. Let's change it over here. Negative and negative make that a positive 8. Inside, we're going to get the square root of 64. 4 times 8 is 32, and this negative. And then we're going to divide everything by 16. 64 plus 32, that's going to give us the square root of 96. Now we might think we're done, but what we have to do is simplify this square root. And so what we're looking for is 96 divisible by a perfect square? What I mean by perfect square, certainly it's divisible by 1, but then there's 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So 96 probably can be divided by 4 or 16. If you try 16, what you'll see is that 96 divided by 16 is going to give you 6. 6 times 16 gives you 96. So what we're going to do to reduce this square root, I'll just kind of do it in this little scratch area, is we're going to rewrite 96 as 16 times 6. And then we can break it into two squares. So 16 times 6 is 96. I haven't really changed anything, but now I can take the square root of 16 times the square root of 6. Square root of 16, since it is a perfect square, I don't know why they use the word perfect, but that's the way I learned it anyway. 16 is, square root of 16 is 4. 6 is, that's as reduced as you can make it. So it's 4 square root of 6. So this now becomes, we'll come back over here, this becomes 8 plus or minus 4 square root of 6 over 16. Notice we can factor a 4 out of the top. So there's a 4 out of here and a 4 out of the 8. So we can take that 4 out. If you take 8 divided by 4, you're left with 2. 4 divided by 4 is 1. So you get plus or minus square root of 6. At the bottom we have 16. And so now we get some reducing. 4 goes into 16 4 times. So there's just a 4 left in the bottom. And so the two answers that we end up with are going to be, now we could leave it all over 4, 2 plus square root of 6 all over 4, comma, 2 minus square root of 6 over 4. So those are the two answers we end up with. Now we have a radical equation that can be solved as a quadratic. And while we don't see a quadratic here yet, if we're going to be able to solve this equation, there's a w out here and there's a w inside. What we're going to do to solve this, the trick we'll use, is we will square both sides. Because if you square a square root, what you end up with is the square root and the square cancel. So we get 6w plus 16 equals w squared. And now it's kind of back to what we did before. We can solve this as a quadratic, but let's get everything to one side. So in this case, it's always nice if there's a 1 in front of the variable part, a positive one. So let's move everything else over here. So you're going to subtract 6w and subtract 16 from both sides. And what that will leave us with is a 0 equals w squared minus 6w minus 16. Now, again, we could solve this with the quadratic formula like we did. Let's see if we can factor 16. That's 2 times 8. That's 4 times 4. And then since there's this subtraction, this negative, we're going to be subtracting. So when we subtract the 2, which one of these pairs, and I guess we could throw in 1 times 16, right? Which one of them, when you subtract them, gives you a 6? Well, 2 minus 8 is 6. So that's the pair we're going to use when we go to factor. We're going to, the first factor, of course, our first term is going to be w, because w times w gives us the w squared, right? The last one to give us our 16 is going to be 2 and 8. And this is what's nice, if we have a 1 in front of the variable, we don't have to worry about positioning. And we're going to subtract, and what we notice is that we end up with a negative 6. So what we're going to want is we're going to want to put the negative on the larger of the two, the larger product. So this is going to give us a 8w, so we want that to be negative. This one will be positive, because a positive times a negative is what gives us a positive. Again, you can FOIL this out and check it, but it will work. And I highly recommend doing that each time until you feel very confident. And you can be careful, don't get overconfident. I do that sometimes. So anyway, we've got two products, two numbers. And so that gives us w plus 2 equals 0, or w minus 8 equals 0. So for this one, we subtract 2 from both sides. We get w equals negative 2. And this we add 8 to both sides, and this gives us w equals positive 8. Now, be careful. We might say, oh, there's our two answers, right? Well, we've got to go back and do a check, because we've got a square root, and they're looking for and we're told that W is a real number. It's not complex. It doesn't have an imaginary part. So what we have to make sure is we don't end up with a negative here. So certainly we could just take 6 times 8, that's positive, plus 6, it's going to be positive. So we're not going to suspect the 8. We're going to say, yeah, that's a good number. But this negative 2 might blow things for us. So we're going to give that a try. I'm going to say if I put in negative 2, does that still give me a real number? That's what I've got to check. So 6 times 2 is 12, so I've got a negative 12 plus 16. Okay, I'm still going to get a positive value. Actually, equals W. What is W? W is negative 2. Sorry, doing a check here. I was messing up. And so negative 12 plus 16 is going to give us 4. This is scratch work sort of check. So I get the square root of 4 equal to negative 2. Why isn't this? Well, that's not going to be true, right? I get 2 equals negative 2. I was thinking that I'd end up with a negative in the square root and say, oh, there's no real number. But either way, is this true? No. So we can't use this as a solution. It doesn't work. Negative 2 is what they call an extraneous solution. So we only have W equals 8 as a valid solution. And again, you could check that out. You put, why don't we go ahead and do it since we're here. 6 times 8 plus 16. Does that equal 8? Well, 6 times 8 is 48. Plus 16. Add these together, you get 50, 64, and the square root of 64 is 8. Yes, I'll say that checks. Because 8 does equal 8. So it checks out here, doesn't work with this one, so we actually end up with only one answer. Okay. So we're at the end of our lecture period, of our direct instruction, I'll call it that. And so now your task is to complete the learning activities in the module. Actually, I'm going to have to fix this later, but I'm glad I saw this. This is actually module A. So we'll get that fixed for us. First time through, we catch some of these things. And then again, if you need any help, any assistance, we've got online tutoring available. Look for your instructor's office hours. Also, working with peers through either discussion forums or people that you know, that can be a helpful way to keep you moving forward and understanding the content. All right. Thank you very much, and we'll see you in Module B.